Hello again. I thought I would talk a little bit about the general theory of arrays and where arrays fit into the larger world of data structures, since we're just now getting into arrays in our C programming class. And I think it's important to know um, how they fit in and what other kinds of data structures, arrays or data structures, might be useful in the future, particularly in other programming languages or as you go forward in your studies. So there's really two things we'll study, two kinds of data structures that we'll study in our C class. Those are arrays, which are just starting now in chapter 5. And pretty soon we'll start into structures, which C calls structs. C has, as you know, to abbreviate everything. And so they couldn't type out the whole word structure. They abbreviated it with the word struct. Those are the fundamental aggregate data structures in C. Now, what I mean by an aggregate data structure is that's a data structure that has more than one variable inside it. And we'll see in detail how this works. We're going to learn how to use each one of these things, arrays and structs, and we're going to learn how to combine them in one project to solve various problems. There's a chapter in the design book on each one, and we will get to it in turn. So let's talk a little bit about variables versus aggregations. Now, you can think of an int or a float or a single character variable as a scalar. It's only got one value at any given point in time. So the name like X or num items or class average, that refers to one and only one value. Yeah, you can change that value because it's not a const. You can change it in your program, but right now it only has one value. Up until arrays, those are kind of like the only sorts of variables you see used much in the text, although they do talk a little bit about character arrays, which form strings. Data structures are aggregates. So these are basically collections that hold multiple values at the same time, and they give you a way to choose which particular variable in the collection that you want. So the individual variables within an array, so we're talking about arrays now, they're called elements, and they're numbered. The individual variables in a struct, for future reference, have their own subnames and are called members. So we'll talk about array elements and struct members. Array elements are accessed using a key or an index or a subscript, which is really the proper term for arrays in C. Now, here's where a difference in perspective exists. Computer science has sort of one perspective on data structures, and we have another to the extent that we're software developers or application developers more than researchers. Computer science students are going to learn, and you'll do this at UCF, you're going to learn the internals of how data structures, and there's lots of them. To name a few, there are trees, lists, heaps, sparse matrices, and others. You're going to learn how those are actually implemented. So what the code looks like to make those things work internally. And you may learn how to design some new ones. And you'll certainly learn how to implement existing ones using C and pointers and arrays. Application developers, mostly that's us. It's certainly true if you're thinking of being a web developer or working in a software application business as opposed to maybe as a researcher. We only need to learn how to be an intelligent consumer of existing data structures. So we need to know what exists, how to use them, like when to use a plain C array versus when you need a C++ map. We need to, at some point, you'll need to understand what a Python list can and can't do and what a Python dictionary does. But mostly, we just need to understand the trade-offs in using these data structures. What can they do? What's their performance? What's their limitations? And we'll see how arrays fit into that in just a minute. Choosing the right data structure makes solving problems much easier. In some cases, if you figure out the underlying data structure that you need, the coding is pretty straightforward. Choosing a wrong data structure makes things really much harder, and likely your program is going to run much slower. So I'm going to go through some terminologies. Some of this is a little meta, but it's useful to know what these terms mean. And I'm hoping you can get enough of this to kind of fit arrays into a mental framework of, oh, okay, arrays are like this, and lists are like this, and trees are like this. So Collection or container. I think Java likes both of those terms. So when you take a Java class, you'll talk about collection classes or talk about containers. That just refers anytime you have more than one variable grouped together for use. So arrays are containers, so are array lists in Java, so are lists in Python, so are maps in C++, and on and on. One variable with a base name grouped together with lots of different members or elements. An element is a single variable within a collection. Specifically in an array, an element is one variable that's accessed with a numeric subscript. An index is the key to finding values. Now, when you're talking about arrays, we call it a subscript, which is a term essentially from mathematics. But if you think of it in a more general term, what you're doing in an array is providing a key, and that key it finds and unlocks a particular element of the array and lets you either read it or modify it. Contiguous, there's a big word for you. It comes up a lot when you talk about arrays because it means literally side by side or touching, like the contiguous United States, the 48 states as opposed to the offshore ones. Array elements are stored contiguously, and that's important. That means are stored right next to one another in memory, and that makes a lot of the benefits of arrays possible. Base name, you'll see that sometimes the compiler comes out with that term. The base name is the name of the array without any subscripts. So if I have an array of ints, it says int my array, bracket 5, close bracket. If you leave off the brackets and you just say my array, that's the base name. And then you take the base name and you apply the subscript operators, which are the square brackets with a number inside, to that base name to get to a particular element. And address. We're going to talk a lot about addresses now, and we talk about how arrays are accessed. And we'll come back, and addresses become very important when we talk about pointers in one of our later chapters. Address is the location in memory where a variable or collection is stored. Now, usually you don't have to think about this. You just give the name of the variable and the compiler finds the address for you. But what happens with arrays is that actually when you give the base name and the subscript, the compiler calculates the address in memory where the value exists and retrieves it for you. And when you're using pointers to make various dynamic data structures like a singly linked list, which we'll do in one of the last projects, then addresses become very important because that's what pointers do. Pointers are variables that contain addresses and let you manipulate the addresses to create dynamic data structures, things where values are not stored contiguously. So now we can define an array more formally. And this is probably, we're dipping our toes into computer science here, but this is probably as far as we're going to get in this class. But you should understand what this means. An array in C is a fixed-sized indexed collection of uniformly typed elements stored contiguously, where the indices must be integral values. Whew. I mean, that's a tough definition, right? But all of the elements are important there. We're going to unpack that one by one so you can understand how arrays work and why they work as efficiently as they do. The collection is just the ability to use a single base name to refer to multiple elements. So that's the name of your array on the left-hand side of the square brackets. An index, or a subscript, is a key that allows you to locate or modify a single element. So when you put the base name and you add the square brackets and you put a number or a variable, an integral variable inside the square brackets, you address a specific element. It says integral values because you can't have an array that's indexed or subscripted, excuse me, with floating point numbers. Because after all, you can't have the 1.5 location. You can have the 0, 1, 2, 3, 4th element, but you can't have the 3.5th element. So the subscripts are constrained to be integral values. That doesn't mean just ints. It could be chars, it could be longs, it could be long ints, but it's got to be a whole number and not a floating point number. Contiguous means the elements are stored side by side. In other words, they're adjacent or next door to one another in memory. If you could see an array in memory, and we'll take a look at a diagram of this in a subsequent video, you would see that the let's say it's integers, are stored right next to one another. So you can simply skip from one to the other by counting. And that is exactly what makes efficient array access possible. The fact that all you need to know to find the array element of the array you want is the base name and the index. Everything else is just arithmetic. Fixed size means that once the array is created, it neither grows or shrinks in its memory usage. And some languages feature dynamic arrays where the array gets bigger as you put elements in it. Vector in C++ does this. Lists in Python do this inherently. But because arrays in C are fixed size, that makes life much easier for the compiler when it generates code because things don't move around. So once you know the base name, you know exactly where all the elements start. The advantages to arrays are speed and simplicity. And arrays are one of the oldest data structures. So they go back to languages that were intended primarily for mathematics, like Fortran, which was a mathematical language that goes back into the 70s. And arrays are also very old, but they're also very efficient. And they're very useful in programs that have to perform at high speed, have to access multiple variables at high speed. Now, that's largely because they're a fixed size, making life really easy when you generate code. Contiguous storage, meaning you don't have to search all over memory to find the next element. You can just move over one address, and there it is. They have an integral index, which means the calculations for where a particular element is in memory are really fast because computers can do, CPUs can do integer arithmetic very, very quickly. And they have a uniform type. In other words, an array is either all ints or all chars or all floats, but it can't be a mixture of those. They're a uniform type, and therefore each element is the same size. And because you know the size, and you know the starting position, and you know the subscript, you can the compiler, can calculate exactly where each element lives in memory. And it can do it really, really efficiently. So the C compiler can generate good machine code for array access. And that's done using something called address calculation that will go into in more depth and in kind of a worked example in a subsequent video. And just remember, you get to an array element by having the compiler calculate for you where it is in memory based on the base name, the subscript, and the size of the element. And really, that's all we have for this video. This is just intended to be an overview. In the next video, we'll look in detail at how array elements are located via address calculation using subscripts, and we might touch a little bit on pointers because we're going to have to circle back to pointers at some time in our class. And I know folks sometimes have some trepidation about that because pointers are traditionally a difficult concept to master initially for beginning coders. That's all I have for now. Thanks a lot, and I'll see you in the next video.